Okay, welcome to Project Obsidian Kill Chain 1 walkthrough. This will be an endpoint forensics walkthrough of the Kill Chain 1 attack simulation for Project Obsidian. Before we get into talking about the kill chain and the artifacts that we're going to look at, I'd like to give a little bit of background about Project Obsidian and a little bit of clarity on what this particular presentation will be. So Project Obsidian is a project, prior to Project Obsidian, it was called Project Capstone. It's been several years in the making. We've been putting this particular, the Obsidian project, together for about 10 months. And Project Obsidian is a way of holistically looking at an attack. So the engineering team for Project Obsidian put together a company in a fake company in AWS. We staffed it with employees, with fake employees, and then ran through an attack scenario. The red team attacked the environment, and you'll see that it's a very close simulation to what an attack would look like. And then the additional Obsidian teams, incident response, forensics, malware reverse engineering, cyber threat intelligence, and cyber threat hunting, all looked at this environment and created education on how each of these teams would approach an attack. This particular walkthrough that we're going to look at is endpoint forensics. Now, the forensics team looked at the SIM, they looked at network detection, and also at endpoint forensics. This is for kill chain 1. There were 3 kill chains: kill chain 1, kill chain 2, and kill chain 3. So this presentation is very targeted. It's the kill chain 1 endpoint forensics, just looking at the forensics on the endpoints. To do this, we used Velociraptor. Velociraptor is a forensics collection tool. So we ran Velociraptor on the machines in the environment and then analyzed those machines. We built a timeline for the series of events and attacks. And then we looked at the artifacts. I'm going to do a demo of the tools at the end, but it's important to realize that this really isn't a presentation to look at just timelining. In fact, timelining is not the focus of this presentation. We're going to be looking at the artifacts that we extracted, how you would parse and analyze those artifacts, and the conclusions that you would draw from them. So getting started, I want to get the timeline understood. We're looking at, there'll be 3 screens here, starting with February 12th. The attack actually started a little bit before this, but to keep the scope small, we're going to be looking at February 12th. First, we see that malicious email was sent in the environment. And we're looking at an employee called Karen Mutants who opened that email and executed the malicious attachment, which then executed malicious PowerShell in the environment. Moving further into the timeline, we'll see that the actor, once they gained access to the network or access to the system, moved laterally and dropped additional malware on the machine. Finally, we'll see that we looked at a number of workstations. Workstation 1 and Workstation 2 are what we're going to cover here, but we also looked at Workstation 3 and we didn't find anything. So it's an important point. I wanted to highlight it in this presentation that you may initially suspect an endpoint. You may do a full analysis on it and not find anything there, and that's okay. So getting into the artifacts and the conclusions we can draw from them. The first thing that we find is that a malicious PowerShell script was executed in the environment. We see this in PowerShell event viewer log, and it jumps out at us because it's using this, it's using a hidden execution, and the PowerShell script is obfuscated. So we're going to grab that data from this event log, and we'll throw it into CyberChef. CyberChef is a great tool for deobfuscating and analyzing data. In this case, the data went through several iterations of deobfuscation, and we'll do a demo of that a little bit later, where we finally came to the conclusion that this was in the bottom. You'll see the bottom right. You'll see the actual C2 server where malware was downloaded from. That is malwarelove.xyz. And if we do an NS lookup on that domain, it resolves to 3.132.192.16. Now, why is this important, and why is this one of the first steps we're going to do? Well, that's because now we have at least some indication of the attacker's activity. We can now take these indicators of compromise. We can scan our entire environment for these indicators. We can add them to our IDS systems. We can add them to our endpoint detection systems. And we can monitor not only to see if there's been further activity in the environment, but we can alert if this actor moves anywhere else in the environment. So this is a very important first step when we are looking at an endpoint and discovering what happened on that endpoint. The next thing we're going to look at here is the malicious email itself. So at this point, we've learned from the incident response folks that a malicious email was sent to several people in the environment. That email had an attachment, which we can see is a base64 encoded MIME attachment. We can also throw that into CyberChef and decode that and save it. This will be our malicious document that we can send to the malware reverse engineering folks, and they can tell us more about what this document does and maybe produce more IOCs from it. The next thing that we're going to find in the environment is that the person that received this email also enabled macros, and we see this in their registry. This is a sysmon log entry showing this, but if you looked in the user's registry, you would see that they had enabled macros. This is another look at it, and I bring this up because what we're going to do is we're going to take a lot of this data and put it into an easy to read format. We use a couple of tools for that. Chainsaw is the tool that we're going to run to look at the event viewer logs. Chainsaw uses Sigma rules, and it will present what it finds in the event logs that are worth investigating. We take that data, which can be produced in comma-separated values. We take that data and we throw it into a reporting tool called Ach Report, and that gives us kind of a nice view, a little bit easier to look at than just all the data loaded up into Excel. The next thing we find in the environment is, since we've run Velociraptor and gathered all of this evidence, Velociraptor collected the network connections and enhanced them. So we see that there was indeed a PowerShell execution. We identified that it was process ID 7036, endpoint 172.16.50.131, reaching out to our C2 server 3.132.196.16. And we can corroborate that by looking at the memory itself. So one of the other things we did when we collected this endpoint was we collected a snapshot of the memory, and then running volatility against that memory collection, we can see not only that Velociraptor found this network connection, but we can actually see it in memory. The next thing we're going to look at, since we now know that process ID 7036 is one of our attacker's processes, we can look at the command line, right? So we're going to use volatility, and we're going to list out all the command lines that will run on this machine and filter it by process ID 7036. And sure enough, we find process ID 7036 was PowerShell, and it has this, clearly malicious PowerShell script that was run, obfuscated. We can then take that. We won't actually do that here, but I'll leave it that for the exercise of the watcher to extract this data, throw it into CyberChef, and decode it. One of the additional things that we're going to do when we're looking in the environment is we're going to ask some common questions, right? And in this case, we ask the common question, hey, are there any executables in temp directories? It's a common thing that attackers do. And in this environment, we find a gold mine of attacker activity. We find a Metasploit, a Covenant, which is a post-exploitation framework, a Covenant agent, and Ping Castle, which is a tool used to look at Active Directory. The next thing we're going to see, since we know from this screen that cleanup.exe is malicious, we're going to look and see, do we find any evidence of persistence? And of course, in our telemetry, using the Velociraptor auto runs artifact, we see that sure enough, a task was scheduled running cleanup.exe, and in a task called Daily Magnum Tempest IT Cleanup. Additionally, looking through the data, we see evidence of enumeration in the environment and for lateral movement, right? So this is coming from the sysmon data, extracted sysmon data. You see the event ID is 1. This comes from running chainsaw against the event logs, and then taking that chainsaw data and displaying it in a format that's a little bit easier to read. So now that we've got a pretty good idea of the kinds of data that we're going to see in this environment, I'd like to walk through a short demonstration of some of the actual tools that we use to do this. So here we see, as we saw earlier, CyberChef, right? And from CyberChef, what we're going to do here is look at this PowerShell event log, right? And I've highlighted here. I'm going to copy this data from the PowerShell event log, and I'll put it into CyberChef. And I've already loaded the recipe up, and we're going to make all of this data available, including the recipe. But I've already loaded the recipe up. Rather than walk through each piece of the recipe, I'm just going to turn the different pieces on to show you how we would decode this. And you can take time in your environment to do the same thing. But first thing that we see, this is obviously base 64 encoded. So we're going to base 64 decode it. And looking at the output, we see that it is Unicode, right? So let's remove the null bytes, the Unicode null bytes, get a nice, better picture. And within this decoded data, we see there is more base 64 decoding, but it's in the middle of the execution. So we want to extract out just the base 64. So we're going to use a regular expression that extracts out just the base 64 data. Now, after we've done that, we can now base64 decode it again, and we're going to see what looks like an archive of some sort, right? We're going to inflate that archive, right? I think zip encoded. I'm not entirely sure which encoding. But again, we're going to see more obfuscation, right? So this is common. You're going to see obfuscation with an obfuscation with an obfuscation. So the first thing we do to make this easier to read is remove all of the spaces, right? After we've removed the spaces, we can then use another regular expression to extract out just the data that we're looking for and remove all of the execution piece, right? So another regular expression. Now we've got the data in decimal. So we're going to take that decimal and turn it into ASCII, right? Now that it's in ASCII, we can see that it's further obfuscated with these plus signs, right? Further activity by the attacker to hide. So let's get rid of the plus signs, and we get now a better picture of what the actual malware looks like. And we'll run the beautifier, and we see what we had seen in our earlier slide of this code reaching out to its C2 server to download malware. The next thing we're going to look at is the actual email that was sent to Amanda Nunsis. And there's really not a lot to learn here other than we can see the base64 encoding, the attachment, and we can then copy and paste that again into CyberChef, which I'm not going to do, but we could copy and paste that into CyberChef and then provide that maldoc to our reverse engineers. The next thing I'd like to do is look at some of the other things that we talked about, right? So one of the things we talked about is on workstation 1, that the trust records. Now this is something called ACH Report. It's simply a tool that runs a lot of other tools and then presents the data in a common, easy to read format. So this makes it a little bit easier for me to present the data. This tool doesn't do the extraction. It's really just a reporting tool. So we're going to look at the enablement of trust record, the enablement of macros on workstation 1. And again, what we see is that this is actually chainsaw output. When we run chainsaw against our event logs, we see that that chainsaw detected that this registry key was changed, and it flags it as a Windows registry trust record modification. So again, important to remember the tools here. You're extracting the event logs, we're running chainsaw against them, and then we're just presenting that data in a little bit easier to view format. On workstation 2, a couple of things we're also going to look at. Again, this is just looking at some of the data we've already presented, but I wanted to show it from the perspective of using the tooling. We're going to look at files that ran out of temp directories. So in this case, what we have here is this tool, ACH Report, took the master file table. We've extracted the master file table from this endpoint. We ran it through a program called MFT dump. That program, MFT dump, takes the master file table and parses it into comma separated values. Then what we did was we simply searched in that comma-separated file and asked, are there any files that are run out of temp directories? And this is a common question that we ask. And we see, again, interpreter, cleanup, and p.exe, right? These three indications of math through these three pieces of malware, right? And in particular, we noticed cleanup, the post-exploitation tool. We're going to look at cleanup, look for occurrences of cleanup. And again, we see the same thing we saw earlier in the presentation, that cleanup was added as a task for persistence. The last thing we're going to look at in the environment is the lateral movement. And I'm just going to choose local group. You can search for a number of things, but here we're seeing that sysmon identified process ID 1 of the actor running whoami, running net.exe to enumerate the administrators, looking at the domain settings. And so this is again from the sysmon logs, but this is chainsaw. Chainsaw we've pointed chainsaw at the event logs, and chainsaw identified this activity as net.exe execution. Okay. Going back to our presentation, wrapping it up, here is a list of the tools that we used to do this investigation. Velociraptor to gather the data, WinPMem to collect the memory volatility, to view the data, and CyberChef, Sysmon, auto runs, MFT dump, chainsaw, and ACH report. And before I end the presentation, let's go back a second and look at that memory, right? One thing I did not demo that I think is worth seeing. And I've just created a very small batch file to show volatility running, right? The first thing we're going to do is look at the memory. We're looking for process ID 7036. And this is, again, what we saw in the presentation. Just wanted to give everyone watching this video a feel for what this looks like. Again, you can run these commands manually or wrap them into a batch file. And all we're doing is running the NetScan plugin for volatility and filtering on process ID 7036. And when this is done, we'll run the second command, which will look at the command lines and filter for process ID 7036. Okay. Our second command in volatility that we're going to run is looking for the command line and not looking at all the command lines. If we just ran command line to command line, we would see all the command lines, but we're really interested in just filtering on process ID 7036, PowerShell execution. And now that we have this data, we can extract that data and throw it into PowerShell. I'm sorry, into CyberChef. All right. And again, the list of tools that we used and an invitation. If you want to learn more about Blue Team Village, please visit us at blueteamvillage.org. You can join the conversation with us on Twitter, or what's even better is to join our Discord. Joining our Discord, we have several channels dedicated to lots of different blue team topics, including forensics. We're going to make all of the data that I've presented, not only just this data, but the other kill chains, the SIM data that we have. There will be a walkthrough on the SIM and IDS walkthroughs. We're going to be making all of that data available to the community. You can use your tools to look through the data. You can use that data for learning more. In other words, you may find something that interests you that we did not investigate. You're welcome to investigate it, join the conversation. And as happens in the security community, new tools are released all the time. Having this data available to you allows you to take that data and test it against new tools, test it against your existing tools, and see if your tools find the same data. Hopefully they do. Or if you see other things that maybe the tools that we use didn't find. So this will all be made available to the community. Please come join us on the Blue Team Village Discord. And that concludes this presentation of the Kill Chain 1 walkthrough.